So starting with my demonstration of 5.2D, I'm Meng Sharma. So starting with the question, open your web browser, and what is given in the question, that is to open your web browser and clear the browser, catch open the Wireshark packet and start the packet capture, enter of a URL with HTTPS in your browser, stop packet capture, and you can start uh, analyzing the packets, explain the operation and the handshake process of TLS using the screen capture of the Wireshark. So here we have taken the screenshot of that. Starting with the so what we are doing here, the client initiate the handshake by sending a message to the server called client hello, which is here, we can see over here, which include details such as TLS version it support, a list of the suits it can use, and a random number. The server responds with a server hello message that includes the TLS version it supports, the suit it has chosen from the client options, and its own random numbers. Then the client generates a random pre-master secret keys, encrypted it with the server public key obtained from the certificate, and send it to the server in a message called client key exchange. Then, if the necessary, the key may also send additional key exchange parameters to the client in message called the server key exchange. The server send a server hello done, which we can observe over here in this screenshots message to indicate that it has completed its part of the handshake. The client and the server both communicate with each other using the agreed upon the inscription and the method by exchange change message. Then at the last, the handshake is completed and the client and the server can now securely exchange the data, the established TLS connections. Now we can move to the next question. The next question is that can you analyze the HTTPS in the Wireshark? Explain your answer. If yes, provide evidence on how we can do that. If not, is there any alternate method we could use to analyze the HTTP? So I have answered that Wireshark cannot analyze the encrypted HTTPS communication because the data transmitted between the client and the server is protected through the encryption provided by the SSL and TLS protocol. This encryption ensures that unauthorized individuals cannot access the data. Wireshark, being a network package analyzer, cannot decrypt the encrypted content of HTTPS traffic. Now moving to the next question, we are provided with that what is the principal application layer protocol used in the emails. So I have answered that the email protocol is SMTP, Simple Mail Transfer Protocol. It is responsible for sending and delivering the email message between the different mail and services. When you send an email, STM SMTP helps establish a connection between your email server and uh, uh, the client email server. It checks the receiver address, transfer the email data, and ensure it reach the intended destination. Other protocol like POP3 and IMAP are used by email client to retrieve email from the mail servers. What is Now we move to the other question. What is the underlying architecture and the transport layer used in the email application protocol? So I have answered that the email application layer protocol such as the Microsoft Exchange server or the Gmail use SMTP as discussed in the previous question to send and receive email message between the service and client like Microsoft Outlook, popularly known for the because of the Microsoft, or the Gmail. This is the communication relies on the client server concept where the servers handle the the deliver and the shortage of the emails, and the client access and manage those emails. For the reliable communication between the server and the client, a transport layer technology called TCP, transport transmission control protocol, is used. TCP ensures that the data is transmitted accurately in the correct order and without errors. It manages the traffic controls, congestions and retardments, any loss or the corrupted packages, ensuring that the email message are sent and received. Now, the other question we have here over here, that is, can you list down the basic steps involved in sending an email from the user A to B? Starting with what I have answered in this question, that is, the user A opens their email client like Microsoft Outlook or Gmail and write the email including user B email address, subject and content. A user A clicks send and their email client connect to their email server provider SMTP servers. Using the SMTP protocol, the email client send the email to the SMTP server. Then the SMTP server verify the user B email address and forward the email to user B email server. By that, the user B email server receives the email and store it in the user B mailbox. At the last, the user B can access the email by opening their email client and connecting to their email server. Now we move to the other layer, that is the transport layer. Starting with the first question of that, the client send a message hello to the server. Once the server receive the full message, server protocol with hello, what's your name? When the client receives the full message from the server, client should be able to enter the name via the terminal and send the name welcome to SIT202 name should be that is received from the client. All this received message should be displayed in the relevant terminal. So this question is done by the Python coding, and starting with, so there is three main component of this: stop and wait, go back, and selective repeat. Starting with the first, this protocol send the data one packet at a time and wait for the receipt to acknowledge each. So here we are discussing how this happens, and uh, it's slow and inefficient because the sender can't send another packet until it receives acknowledgement from the previous one. Then we go to the go back, and this slide the window protocol allow the sender to transmit multiple packets without waiting for response. Acknowledge after receiving a window of the packet. If the sender does not receive an acknowledgement in the time, it assumes the packet lost and thus resend the entire window. Selective repeat, another sliding window protocol where the sender can transmit multiple packets without waiting for the acknowledgement. Once the lost packet are transmitted, the receiver kept and buffer for the message and request a transmission for any lost packet. To achieve the client and the server interaction, you can use a programming language like Python and its socket module to establish a socket connection between the client and the server. Here is an example which will be going to be discussed in the other slide. So this is the server and the client code. Selective repeat is another slide window protocol in which the sender can transfer multiple packets without waiting for the receipt to acknowledge them. Unlike the go back and once lost the packet, and each message is kept in the receiver buffer, and if any of are lost, the receiver requests the this to method is most efficient than the stop and wait and go back end, as it only sends the lost packet, reducing the network traffic and latency. Now we move on to the next layer. Its first question is PC1 in the above diagram can now wants to send a message to another PC5 with the IP address of 198.168.2.4. Discuss how the PC5 is connected to the current network. Starting with what I have answered in this question. In this setup, we have a router connecting three switches, created three separate network to establish the communication between the computer. In this network, we set a default gateway. For example, PC1 is connected to the first network and PC5 is connected to the third network. By setting the default gateway of for each computer, we establish a connection to the router. Now if we want to send a packet from PC1 to PC5, we specify the IP address of PC5 as destination address. The router then take the care of the routing the packet through the appropriate network to reach PC5. This configuration allow all three network to connect and communicate with each another. The router act as a central hub directly the network traffic between the different network, ensuring that the packet reach their intended destinations. Uh, Now the other question, that is the add PC5 and the other devices if necessary to the network. You can build in activity 2 and verify the connectivity using the pinch if in one of the PC5. So the following steps are: connect the PC5 to the switch 3, ensuring that the connection is proper established. Configure the network setting on PC5 including the IP address, subnetting mask, default gateway, a unique IP address to PC5 within the same IP address range as the other PC5 in the network but with the different host position. One and PC within the network. Open the command prompt or the terminal. Use the pinch command followed by the IP address of the PC5 to initiate the pinch request. For example, if the PC5 has the IP address of 9192.68.1.5, you can use the command pinch 192.168.1.5. If the network and the connectivity are properly configured, you should receive a response from the PC5 indicating a successful pinch. This means that the PC1 can successfully communicate with the PC5 over the network, which we have done over here in this snapshot. And let's move. So the next question is the difference between the inter-AS and the intra-AS protocol used in the internet. What are the example of these two different type of the routing protocol? So the inter-AS and the intra-AS protocol are used, firstly are used for the communication and routing is in different network domain. Intra-AS protocol help transferring the routing data across multiple autonomous systems on the internet, while the intra-AS protocol are used for the communication within the single, and the intra-AS protocol are used for the routing domain where the routing routers within the same AS exchange routing information. The intra-AS protocol on the other hand are used for the different between the domains allow. And so the next question is, what is the crossover Ethernet cable? When do we need to use a crossover Ethernet cable? So a crossover Ethernet cable is a type of the cable used to connect the two devices of the same kind, such as PCS or the two switch. It is called the crossover because the pattern of each end of the cable is crossed or swapped. The crossover Ethernet is need when the connecting two identical device because the both the transmitting and the receiver data on the same wire. If a regular straight throughout the Ethernet cable is used, the transmit pins on the one device with the connected to the transmitter pins on the other device and receive pins with a connected receives pins. This will result in the communication problem. With this we come to an end, so thank you.